Good morning, students. Today we will continue this chapter. So open your book at page number 102. Let us read. Solute, solvent and solution. A teaspoon of sugar is added to a glass of water. The spoon is used to stir the contents of the glass. The sugar crystals swirling in the water soon decrease in size and then disappear. Where does the sugar go? The water now tastes sweet. This is because the sugar has dissolved in the water. To dissolve means to mix completely. The sweet syrup in the glass is called the solution. The sugar that was added was the solute. The water to which the solute was added is called solvent. Thus, solute is sugar plus solvent, which is water, equal to solution, that is syrup. So, the sugar is solute, the water is solvent, and the syrup is solution. Measure the volume of the water in a graduated flask. Add a teaspoon of salt to the water. The water tastes salty now. We now have brine or a salt water solution in the flask. Note down the volume of the solution. Add another teaspoon of salt. The solution tastes more salty. Did the volume of the solution increase? No, the volume of the solution does not increase. Water and sugar makes a solution, which is a syrup. Salt and water makes a brine, which is a salt water solution. If you find the volume of the salt solution is the same as volume of the solvent or water that we started with, so where did the solute go? The salt crystals broke down into molecules which occupied the intermolecular spaces between the molecules of water. Thus there was no change in volume. Fill a beaker to the brim with marbles. Now pick up a fish and let it trickle into the beaker. Shake the beaker a little. The sand finds its way to settle in the spaces between the marbles. You can add more sand, but the marbles will not overflow from the beaker. The marbles are like the molecules of the solvent, and the sand represents the molecules of the solute. Imagine this is a solution, and imagine the added salt is like the solute, and marble balls represent the molecules of water. So we can see that the sands can easily adjust in the empty patches of balls. So the salt water solution did not overflow as the marble balls did not overflow. Shaking the beaker allowed the sand to settle in the spaces between the marbles. Similarly, stirring the solute in a solvent helps it to dissolve faster. A powdered solute also dissolves faster. Add a teaspoon of sand to a beaker full of water. Stir it well. After a while, the sand settles down. It does not dissolve in water. Add some candle wax in water. Does it dissolve in water? No. Sand and candle wax are insoluble in water. Sugar and salt are soluble in water. Candle wax, however, dissolves in kerosene oil. Paint and grease also dissolve in kerosene oil. So something dissolves in water and something does not dissolve in water. So wax and sand are insoluble in water, but sugar and salt are soluble in water. Paint, grease, candle, these are soluble in kerosene oil. The above are the example of solid solutes. Liquid and gases also dissolve in liquids. Oil dissolve in petrol. This is why dry cleaners, petrol wash oil stains from clothes. Alcohol and milk dissolve in water. Gases like oxygen, carbon dioxide and nitrogen dissolve in water. This is why aquatic plants and animals breathe in gases dissolved in water. A soda bottle opens with a pop and the bubbles hiss out of the soda with a fizz. This is carbon dioxide gas which is dissolved in water to make soda. Gases dissolve in water. This is why aquatic plants and animals can breathe in water, and liquid also dissolve in liquid such as oil can dissolve in petrol. Okay student, look, today we will learn question number A, C, D, E, F from question number 1. Okay, so this is your homework. Look, I have written the answers here, so read and remember this and do it in your copy. Hope today's topic is clear. See you in the next class. Bye bye students.